Okay, example 14 has the limit as x approaches 0. You would simplify this to be 1 over x squared, and you're still going to get a 0 in the bottom. And so what do you do? Okay, you finally got one where it's not to infinity, it's to a 0. That the limit is not going to exist. Again. Remember what this really looks like. This is this, right? This is 1 over x squared. So they both equal infinity, but overall you would say that the limit does not exist. Okay, it approaches infinity, but it does not positive infinity. The limit doesn't exist. So you can say, though, that the limit as x goes to 0 equals positive and approaches positive infinity. Okay. All right, example 15 says the limit as x approaches 1 of x squared minus 1 over x squared minus 1. Well, that's just the limit as x goes to 1 of 1, which equals 1. All right. This looks a little crazy, but just act like delta x is a variable. So, you have a 0 on the bottom, but you don't know for sure. You haven't simplified this to see whether or not that delta x can go away, so you can't just say it doesn't exist. You have to actually work it out. So you see that if you simplify this, multiply out the FOIL, the factor there, the binomial, you get 6 delta x plus delta x squared over delta x, which is equal to 6 plus delta x. And that's the limit as delta x approaches 0. So what we did was simplify the function now, which you can't say there's no limit if you haven't simplified all the way. So just simply put in 0 for delta x and you get 6. Looking at number 17 closely, if you just stuck 0 in, you'd end up with a 1 over 0 here. So you've got an issue. You've got to simplify this guy first too. So the limit as h goes to 0, and let's multiply this out, would be 1 over h times 2 plus h minus 1 over 2h. So it looks like we have a common denominator of 2h, 2 plus h. So this is missing a 2, because if I multiply top and bottom by 2 over 2, I will get 2h, 2 plus h, so 2. And then minus, this side is missing a 2 plus h, so minus 2 plus h. So this is the limit as h approaches 0 of 2 minus h over 2h, 2 plus h, which is equal to a negative h over 2h, 2 plus h. And look what happens. Boom, boom, crosses those out. All of a sudden, you can take the limit as h approaches 0. So that's negative 1 over 2 times 2 plus h. So it's negative 1/4. Now, look. Here's the deal. If you get a 0 in the denominator, it better be simplified before you say DNE. Otherwise, like denominators, all that stuff, to try to get it to work out, okay? All right, looking at 18, I'm going to infinity, so I'm looking at the end behavior, right? So I'm looking at a negative x over an x squared, right? And so I've got a higher degree on the bottom, so this is going to be equal to 0. No problem there. Higher degree on the bottom than the top means this will be getting larger, faster, approaching 0. Okay, quick way to do this infinity one. If I were to do long division, okay, notice the degree on the top is bigger than the degree on the bottom, so it's not going to 0. So, obviously, if I crossed out and pretend this was nothing, and why? Because if you're doing end behavior, that stuff doesn't matter at the end. So I'm looking really at 4x to the fourth, I guess, over 37x cubed. And so I would end up crossing that out, and I would get 4x over 37. Okay, and so if I'm going to infinity, that function is going to infinity. All right. Bottom line, if the degree on the top is bigger than the degree on the bottom, I was going to say, if you did long division, 4x to the fourth plus 5x plus 1 divided by 37x cubed, you'd get an x here. You'd get 37 over 4x, right? But anyway, you get an x, and you can tell that's going to be linear. It's going to be infinity. Okay, number 20. We're going to infinity, so we're looking at end behavior, and you gotta, even though they put it out of order, here's my highest degree, and here's my highest degree. So, when they have even degrees, it's the coefficients over each other. So that would be -1/2. So the answer would be -1/2. Fastest way to do it.